Hello again. Welcome to another lesson in geometry. Today we are covering section 10-5, trigonometry and area. So first our warm up here, we have some vocabulary. Underline the correct word to complete the sentence. So area is the number of square units needed to cover a given surface. Remember, cubic is going to be our volume units. What is the formula for the area of a triangle? That's going to be 1/2 base times height. So we can cross out that one, which is a parallelogram, that one, which is a trapezoid, and that one, which is a kite. Okay. Vocabulary builder, trigonometry. Other word form, trigonometric, that's an adjective. And some related words are cosine, sine, and tangent. So we spent some time on our trig before. So definition, trigonometry is the study of the relationship between two sides and an angle in a right triangle. So our main idea is you can use trigonometry to find the area of a regular polygon because they're going to have right triangles embedded inside of them. All right, so complete each word with the trigonometry or trigonometric. So the sine, cosine, and tangent ratios are trigonometric ratios. Okay, and this year I am studying trigonometry and math. So that's our noun. Trigonometry. There we go. All right, draw a line from the trigonometric ratio in column A to its name in column B. So we have leg over hypotenuse. We have the adjacent leg, so opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So remember we learned this to help us put them together. So SOHCAHTOA. So the sine is going to go with opposite and hypotenuse. So the first one is opposite and hypotenuse, and that should go for sine. And then cosine is going to go with adjacent and hypotenuse. So adjacent and hypotenuse go with cosine. And then the last one, tangent, T, goes with opposite and adjacent. So opposite and adjacent. So remember, sine, cosine, tangent, and then OH is opposite and hypotenuse, AH is adjacent hypotenuse, and OA is opposite and adjacent. Okay, on page 2, we're going to learn how to find the area of a regular polygon when it can't be divided into like a 30, 60, 90 triangles, not the special ones. Okay, so finding area. So what is the area of a regular pentagon with one side of 4 inches? Round your answer to the nearest square inch. So we're not going to get exact answers here because we're going to have to use some trigonometry to find our links, but we can still get pretty good answers. Okay, so underline the correct words to complete each sentence. So to find the area using the formula A equals 1/2 times the apothem times the perimeter, you need to know the length of the apothem, not the radius, and you need to know the perimeter of the pentagon. Okay, so in a regular pentagon at the right, label center C. So center C is going to be here. Apothem CR. So apothem, remember, is from the center to one of the edges, so it forms a right angle, so it's perpendicular. And then the radii CD and CE. So I need E and D here. Okay. So the perimeter, well, I should probably put them in order. Let's go with D and E. It'll match our stuff later. So the perimeter of the pentagon is 5 times 4 inches, because there are 5 sides and each one's 4 inches big, or 20 inches, okay? The measure of the central angle, DCE, is 360. Remember, there are 5 central angles in a regular pentagon, so 360 divided by 5, which gives us 72 degrees, okay? Complete exercises 12 and 13. So the measure of angle DCR. So DCR is this angle in here, which is going to be half of our central angle. So it's going to be half of 72 degrees, or the DCE, which is our central angle. And half of 72 is 36 degrees. And then we want to find the length of DR. And DR is half of one of the sides. Okay, so it's going to be half of DE, which is half of 4, because one of our sides was 4 inches, which is going to be 2. All right, so we're going to use our results to build a little right triangle, this right triangle, by itself, so we can find the missing apothem that we need. All right, so we have the apothem labeled A. We know our angle is 36 degrees, and we know one of the sides is 2. All right, so if we look at this triangle, what we're looking for is the apothem. We know the angle C here, so that's apothem is adjacent to it, and we also know the angle the side that's opposite of angle C. So we have adjacent and we have opposite. Those are going to go with tangent. Okay, so SOHCAHTOA will help us out here, opposite over adjacent. All right, so we're going to find the right trigonometric ratio here to help us figure this out. So we're definitely going to be using tangent, and it's going to be tangent of our angle, which is 36. So we can mark out the 72s out of here. Okay, and then our sides are the opposite is 2. So that only leaves this one over the adjacent, which is the apothem. All right, so use the justifications below to find the length of the apothem and then the area. So the tangent of 72 degrees is equal to 2 over the apothem. So the tangent of 30, ooh, what in the world are they doing there? This should say, there's a typo in this, this should say the tangent of 36 degrees. I don't know why they have a 72 in there, is equal to 2 over the apothem. All right, so then they move the apothem length over to the same side as the tangent, and then they divided the tangent 36 to both sides to get 2. Okay. All right, so A is going to be 2 divided by the tangent of 36. Now we're not going to work that out yet. We're going to save it for when we type on the calculator all at the end. So we're going to have 1/2 times the apothem times the perimeter, which was 20. We found that above. And then we type that on our calculator, and we're going to get about 27.5276388, bunch of other stuff. So remember, this is an irrational number, so it'll go on forever. Okay, so to the nearest square inch, the area of the regular pentagon is going to be 28 inches squared. Okay, so we could fill that pentagon with 28 little squares. All right, let's flip it over and see what's on page 3. Okay, on the top of page 3, we have problem number 2, finding area. So we have another practice problem just like we did. So a tabletop has the shape of a regular decagon with a radius of 9.5 inches. What is the area of the tabletop to the nearest square inch? So what do we know? Well, the only thing we know is that the radius is equal to 9.5 inches and that it is a decagon. Okay, what do we need? Well, we need to know the apothem length. We need to know the perimeter, which means we'll need to know a single side. So, and then we're going to need to find the area, of course, okay, because that's what it asks us for. So use trigonometric ratios to find the apothem and the length of a side. So look at the decagon at the right and explain why the measure of each central angle of a decagon is 36 degrees. And the measure of angle C is 18. All right, so to get the measure of all the central angles, there are a total of 360 degrees in the center. There are 10 sides in a decagon, so that's going to give us 36. All right, but angle C is only 1/2 of a central angle. Okay, and we knew that our central angle was 36, so half of 36 is going to give us 18. All right. All right, use the cosine ratio to find the apothem A. So the cosine of 18, all right, so our 18 is this angle in here, angle C. And notice that we're touching the hypotenuse, and we would really like to know the apothem right now. So that's the adjacent. So that's why they did cosine. So SOHCAHTOA, we were using the adjacent and the hypotenuse. So the cosine is going to be, of 18 degrees, is going to be A over 9.5. Okay. And then we can solve for A if we just multiply 9.5 to both sides. So there's the length of the apothem, an exact answer, 9.5 times the cosine of 18. Now use the sine ratio to find x. So the sine ratio, why are we using sine? Well, here's c. One more time. Let's do this in blue this time. Okay. And across from c is what we're looking for. That's half of one of our sides. That's x. So that's opposite. And then we still know the hypotenuse of 9.5. So that goes with sine. So the sine is going to be x over 9.5. And then we'll multiply 9.5 to both sides to get x by itself. All right. Now, use the justifications below to find the perimeter. So the perimeter is going to be equal to 10 times the length of one side because we have a decagon. Okay. So that's going to be 10 times. And let's see, so we have 2 x's to get a side. So x was half of one of our sides. So that's going to be 10 times 2. And then we knew the length of x was 9.5 times the sine of 18 degrees. All right, so if you multiply 2 times 10 times 9.5, this is going to give us a total perimeter of 190 sine 18. All right, so now we're going to find the area. Okay, we're going to use a calculator to help us, but we're going to start with our formula and put in all the parts. So 1/2 the apothem times the perimeter, which is 1/2, and then our apothem was 9.5 cosine 18. And the perimeter was 190 sine of 18. Okay, and then if we type all that stuff on our calculator and round it, because we're just trying to make a rounded answer, we're going to get 265.23809 other stuff. Okay, so we're going to round it to the nearest square inch, so that's going to be about 265 inches squared. All right. Theorem 10-8, area of a triangle given SAS. So the area of a triangle is half the product of the lengths of the two sides and the sine of the included angle. All right, so let's see what this says. So the area of triangle ABC is equal to 1/2 of BC. Okay, so these are our two sides. This is B side and this is C side multiplied together times the sine of angle A. Now, why did we pick A here? Why not angle B or angle C? Well, it's 1/2 of two sides times the included angle. The included angle in this case for sides B and C is angle A. Angle A is included between B and C. So our formula, a new formula for finding area of a triangle, is equal to 1/2 times B times C, where B and C are two of the sides, times the sine of the angle that's in between them. So in this case, sine of angle A. Okay, on page 4 here, we have problem number 3, finding area of a triangle in this case. And we're going to use a formula that we just learned. So we don't have to know the base and height of the triangle anymore. We're going to use this new formula. So what is the area of the triangle? Round your answer to the nearest square inch. So notice we have two sides, 16 and 10. And then we have the included angles measure, 34. Okay. So I know the lengths of two sides in the measure of the included angle. The side lengths are 10 inches and 16 inches. And the angle measure is 34 degrees. So we can use our formula for side angle side for a triangle. So we do 1/2, okay, times the two sides times the sine of the included angle. All right, so then we just type on the calculator here, and this will make about 44.73543, etc. Okay. And to the nearest square inch, the area of that triangle is going to be about 45 inches squared. All right, so we have a lesson check. As always, you should pause the video, try the lesson check yourself, and then come back afterwards. But welcome back. All right, so area analysis, your classmates needs to find the area of a regular pentagon with 8 centimeter sides. Okay, to find the apothem, he sets up and solves a trigonometric ratio. What error did he make in his ratio here? So the lengths of the legs of the triangle in a regular polygon are going to be A and 4. So this is what's going on here. So we have a regular pentagon, and it has 8 centimeter sides. So there's our 8 centimeters for that. And we have the lengths are going to be A and 4 for our triangle. So if we split off this little triangle in here, we have A for the apothem, and we have 4 for half of one of the sides. Okay. So the tangent of 36 is the length of the opposite leg over the length of the adjacent leg. So where did the 36 come from? All right, so let's see. We had a pentagon. So 360 divided by 5 will give us 72. But that's the whole central angle. So remember, we're going to do 72 divided in half to get half of our central angle. So this would be 36 here. That's where the 36 came from. So the tangent is supposed to be the opposite over the adjacent. All right, so the tangent of this angle should be 4 over A. Okay. Explain the error that your classmate made. So they said the tangent of 36 was A over 4. So what did they do wrong? Well, they put the opposite and the adjacent in the wrong spot. In the tangent ratio. All right, so it should have been the tangent of 36 is 4 over A. Okay. All right, so that concludes our lesson for today. We'll practice this, which will give us a good chance to do some extra practice on our trigonometric ratios. All right, so check out the vocabulary words that you understand. You should definitely understand what area means, just how many square units to cover something. And we spent a lot of time on trig here, so we should have a good idea of this. So how well can you use trigonometry to find an area? You should be somewhere in here. It's just finding that same little half of a central triangle kind of thing. And then finding the missing sides using trig this time instead of special triangle ratios. All right, I'll see you in class next time to do some practice.